Okay, we are looking at our very first lesson involving quadratic relations, which is a very fancy way of saying a word that you may or may not be familiar with, which is the word parabolas. And what a parabola looks like is all of these things that you see on this page here, all of these U-shaped things. Sometimes they face up, sometimes they face down. But whether they face up or down, they are still very much a parabola. They always look like a little U. Now there are some key points on our parabola that we are going to talk about. The first thing, and probably the most important thing, or one of them, is what we call our vertex. So here's our vertex. It is our top or bottom point. So if you look at graph B here, does it have a top or a bottom? Well, this thing definitely has a bottom. It's still called a vertex. What about graph D? Does it have a top or a bottom? Well, it has a high point, and we still call it a vertex. So the vertex, which is our first definition, is the highest or lowest point in a parabola. So that is good to know, but how do we know if there's a high or a low point just by looking at it? Well, it's really easy to remember. If the graph opens up, that means your vertex, look at it, in both A and B it opened up, we had a low point, it means we have a minimum, which means a low point. And if it opens down, like it does in C or D, that means you have a maximum value for your vertex, aka a high point. So the vertex is very important that way. And the vertex is also important because it talks about our next definition, which is what we call our axis of symmetry. And remember, symmetry is all about being the same on both sides of a line. So here I could draw like a nice little line right down our vertex, and this side is going to be the exact same as that side. And I can do it to any single one of these graphs, this axis of symmetry. So if I wanted to write an equation for this line, our axis of symmetry, how would I do it? How would I specify what that line is? The axis of symmetry is just the x coordinate of the vertex. And it just tells us what line is this parabola symmetrical through. So if I'm looking at this, for B here, what would the equation of the axis of symmetry be? Well, we would just say it's x equals whatever the point it is passing through. And it's passing through -2. It's really that easy. That's how you write an axis of symmetry. So if I wanted one for E, what would be the equation of my axis of symmetry? Well, here is my line of my axis of symmetry. It's the x coordinate of my vertex. So for that one, it would be x equals +1. Okay. The most important thing, and the thing that we're probably going to spend the most time doing in this course, is what we call our x-intercepts, also called our roots. That is where this graph hits the x-axis. And you'll notice there are a whole lot. So it's cool because parabolas can either have two, like they do in FDC. They could have one if our graph looked just like this, and then it's only got one x-intercept, or they can have 0, like they do in E, because that graph is just raised up. So the x-intercepts roots, these are the points at which the graph hits the x-axis. So for F, for instance, what would be the points of those? Well, it hits it at -2, 0, and it also hits it at this point over here, which is 2, 0. So that's how we generally write roots. We have our x coordinate, and we have our y-coordinate. Our y-coordinate's always going to be 0 because that's how you know it's on that x-axis. So those are our three big definitions when it comes to parabolas, but how do you know something's a parabola, especially if you're just given a table of values? Well, we know how something we knew was a straight line. Remember, our first differences were always the same. That rate of change was always the same. It's kind of like that, except we need to extend it to our second differences. So what we're going to do there is, if we take a look at any chart, we can take a look and say, okay, are these things quadratic, are they linear, or are they neither? And the easiest way to do that is just to examine what the second differences are. So here, let's see if I can cut this out. Nice. Oh, so cool. So what we're going to do here is take a look at our first differences. So the first difference here, 2 minus 1 equals 1. 3 minus 2 equals 1. 4 minus 3 equals 1. 3 minus 4 equals negative 1. 2 minus 3 equals negative 1. And 1 minus 2 equals negative 1. So the first differences here don't tell us anything. What about the second differences? So now we're going to take these numbers and we're going to subtract them. 1 minus 1, 0. 1 minus 1, 0. Negative 1 minus 1 equals negative 2. So we're already in a situation here. This graph tells us a whole lot. We know that the first differences were not equal, which means it is not linear. The second differences are not equal, which means it's not quadratic or a parabola. This graph would be neither. Okay? So we can do that to any graph at all, and we could figure it out. So what I'm going to do there is I'm going to give a sample graph. So y equals x squared plus 2x plus 1. You know that something is quadratic because it has this. If it has this little squared thing in it, you know it's automatically a parabola. But let's say I said, why don't you go ahead, make a table of values, and we'll investigate. We can go ahead and do that. So what we'll do here is we'll make a table of values. We'll look at 0, 1, 2, 3, and we'll plug it in. So we're going to use y equals 0 squared plus 2 times 0 plus 1. And if you put that in your calculator, that's going to give you 1. Y equals 1 squared plus 2 times 1 plus 1. And that's going to give you 4. Y equals 2 squared plus 2 times 2 plus 1. And that's going to give you 4 plus 4, so that's going to give you 9. And the last one is y equals 3 squared plus 2 times 3 plus 1, which is going to give you 16. So now let's take a look at our first differences. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. Now let's look at our second differences here. So we'll look at those two. 5 minus 3 is 2. 7 minus 5 is also 2. And if we had more data, we would see that all of these things are the same. So our second differences, this was our first difference, this was our second difference, these things were equal. And what that means is that if they are equal, we have a quadratic relation on our hands. And is that what we expected? Well, of course, we have this equation for a parabola, this y equals x squared. It's kind of how we tell that something is going to be a parabola. Today is just getting you used to working with parabolas and investigating some of this stuff. So it's a nice quick lesson, and the homework shouldn't be too bad either. So make sure you do it, take some time. If you need to get caught up on any of the other quizzes or the test, make sure you are doing that as well.